Hello, my name is Adam Rice. I'm the leader of Team 5, and this is our project final presentation. This presentation will cover our needs statement, concept of operations, market analysis, financials, value proposition, planned cost structure, and project management plan. Our project focuses on ladder fall prevention. The goal of the project is to evaluate possible product concepts, select the best solution, and develop a business plan for that product. Up first is the needs statement. Each year in the United States, approximately 500,000 people are treated in emergency rooms for ladder-related injuries, and about 300 of those are fatal. The Occupational Safety and Health Administration estimates a single non-fatal ladder injury costs an employer an average of $41,000. A fatal accident averages $1.2 million in workers' compensation and administrative costs. Ladder injuries in the United States create a total financial burden of approximately $24 billion annually. These injuries often occur during common household and work-related tasks, making ladder safety a widespread concern for both homeowners and professionals. Accidents happen during activities like performing construction tasks or maintaining a home. Because these tasks are so common, the number of people exposed to ladder hazards is very large. A major issue with ladder use is that unsafe conditions may not be obvious to the user. A ladder may appear to be stable at first, but be at an unsafe angle, loaded unevenly, or beginning to shift during use. By the time the user recognizes the problem, it may already be too late to correct it safely. There is a clear need for an improved ladder fall prevention solution that helps users recognize unsafe conditions, maintain proper stability, and reduce the likelihood of falls before they happen. A successful solution should be simple to use, affordable, compatible with common ladder types, and effective at reducing injuries and deaths associated with ladder use.
Hello, my name is Mohammed Ramethi. I will be covering the concept of operations, function analysis, and system requirements for our ladder fall prevention system. For the concept of operations, the system is designed to check the ladder before the user climbs and continues monitoring it during use. The user positions the ladder, powers on the system, sensors, then check the ladder's angle and the pressure at each ladder foot and ground contact. If the setup is safe, a green light appears. If it is unsafe, the system gives a visual and an audible warning so that the user can correct the ladder before climbing. While the user is working, the system keeps monitoring for changes such as shifting, uneven pressure, or loss of ground contact. As for the functional analysis, the functional analysis shows how the system makes that decision. So after power on, it measures the pressure, ladder angle, and ground contact. Those measurements are compared with the safe limits. If the conditions are acceptable, the green light allows the user to climb. If not, the warning activates and then the user repositions the ladder. The same process continues during use. Measure, compare, decide, respond, and repeat. As for the system requirements, to make sure the system performs correctly, we developed a measurable system requirement. The safe ladder angle is 70 to 80 degrees. Each foot must have at least 5 pounds of load with no more than 15% variance. Unsafe conditions must trigger a warning within half a second. The visual warning must be at least 50 candela and visible from at least 10 meters in daylight. The battery must last at least 8 hours. The system can add no more than 2.5 pounds to the ladder. Our estimated unit cost is around $100. Finally, this system must survive a 1.5 meter drop and meet an IPX6 water resistance rating. These requirements are specific, measurable, and testable. Thank you.
We will now take a moment to talk about the market analysis performed for this project. Our product is an aftermarket ladder safety accessory designed for homeowners and professional contractors who already own conventional ladders. Instead of requiring users to purchase a more expensive smart ladder, our system provides a lower cost way to improve safety by monitoring ladder stability and warning the user when unsafe conditions are detected. There is a clear need for this type of product. Approximately 500,000 people in the United States are treated for ladder-related injuries each year, with about 300 fatalities. Ladder accidents are also a major workplace concern, especially in construction and maintenance occupations. The market opportunity is significant as well. The North American ladder market was valued at approximately 1.25 billion in 2025, and there's already a large existing base of homeowners and contractors who own ladders. Because our product can be added to equipment people already have, customers can gain additional safety features without replacing the entire ladder. The product could be sold through hardware stores, online retailers, and potentially through partnerships with established ladder manufacturers. Existing ladder accessories already on the market also show that customers are willing to purchase add-on products that improve safety and usability. From a technical standpoint, the concept is practical because it relies on established sensors, battery-powered electronics, and warning systems. While issues such as battery life, maintenance, competition, and changing safety standards will need to be addressed, none appear prohibitive. Overall, the market analysis supports moving forward with the concept because it combines a demonstrated safety need, a large customer base, an affordable value proposition, and practical technology.
Hello, my name is Said Borges, and today I'll be discussing about the financials regarding the project. So we would like to ask for an investment of $75,000 so that by the end of the payment, the quarterly payment, we hope that the project will be fully realized and be sent to the public. So for our first quarter, we hope to have an investment of $20,000 and design the product to then fully into fully functional prototype so that it will be available for testing. For the second quarter, and speaking of which we hope that by then we'll have another investment of $25,000 so that we will go over soft tooling and extended battery drop testing and other their testing verification so that once everything meets the requirements and functionality, we can begin manufacturing. And then with the third quarter, we hope an investment of $20,000 will be made while we do a pilot lid run of the device as well as packaging so that we'll see if the supply does meet the demand. And then by the end of hopefully by the fourth quarter, we'll finish up with an investment of $10,000 so that we'll have marketing and any modifications to the project and as well as warranties so that the product will be released. Yes, and with that in mind, hopefully we'll sell the product for $64, in which by then it will pass the required 1,872 unit. That's to make a profit of $119,000 and 808 cents. And then with that in mind, then our goal, well, our value proposition is that the product is a lightweight, fluid, and affordable add-on device that continuously monitors ladder angle and ground contact that instantly alerts users to unsafe conditions so that they can set up and work with confidence while reducing fall risk without altering how ladders are used or stored. And now I'm gonna pass the baton to Braden, and thank you so much for your time.
Hello, my name is Braden Francic, and I'll be going over the planned cost structure for our product as well as the planned price point that we hope to achieve. Starting off with our cost structure for materialistic resources, these include things such as necessary equipment, materials, and facilities for developing and prototyping and manufacturing our product. We hope to spend around $20,000 for direct costs. These are things such as the pilot manufacturing launch, which actually takes up the majority of this at around $20,000. And for indirect costs, we hope to spend around $11,000, which is mainly taken up by office capital, and prototype manufacturing. So in the end, we would have spent around roughly $31,000 for the materialistic resources necessary to take on this project. Moving on to our personnel planned cost structure. During quarters 1 and 2, we will be focusing primarily on development as opposed to production. So we will have more indirect workforce than our direct workforce, but not by much. As we move on into quarter 3 and 4 of year 1 and into year 2, we will begin to expand our direct workforce much more than our indirect workforce. And at full capacity, we plan to have around 228 total hours worked while producing 250 units per month. Which brings us to our planned price point. We estimate the cost to produce per unit is around $15, which makes the ideal price tag around $75. This price is affordable while also meeting the needs of the company. And in the future, we should absolutely find a way to lower the cost. To once the company has made its initial investments, we can have this product serve as passive supportive income. And one way we could absolutely boost sales at launch is if we happen to secure a deal with a ladder manufacturer early on. And it should be an opportunity we look for, especially early on. Hello, my name is Braden Frantic, and I'll be going over the project management for our product. Starting with the work breakdown structure, there are 7 major steps that we need to complete before we can consider our project successful. Those being the concept and requirements. This is where we go over the system requirements, the customer requirements, as well as the overall concept. The product design, where we need to develop schematics and ideas for the actual design of the product. Then we go over the component and material selection, where we actually need to choose what our product will be made out of. Then we have the prototyping and software development. This is where we actually make a functional prototype. It doesn't have to be pretty, but a functional working prototype and software for testing. And then moving on to testing and revision. This is where we make sure that everything of the product actually works correctly. And if it doesn't, we can make changes for the second prototype. And then during verification and validation, this is our final just double check of everything that we need to go over before we actually finalize the product. And then there's actual product finalization. This is where we make sure that the product meets the requirements for the customer, and we meet with them, and we send it off to manufacturing. Moving on to our Gantt chart. This chart depicts how we will be implementing our work breakdown structure into an actual plan. For quarter 1, we will be going over and discussing the customer's requirements as well as the system requirements, coming up with a concept for our product. And by the end of it, we hope to begin prototyping. By quarter 2, we will be prototype developing and software developing our product. And by the end of it, we hope to have a functional prototype. Quarter 3 will see us testing and revising the functional prototype and making changes as we see fit. And by the end of quarter 3, we really hope to have a functional finalized prototype for review. Quarter 4, we hope to validate and verify our product and make a manufacturing deal and have a manufacturing launch at the end of quarter 4.